All right. Okay. Hello. So, hey everyone. Hello. Hello. So, I opened Claude not just to demonstrate that I don't tell the worst jokes. ChatGPT tells worse ones, but also to just kind of make sure that people know, because the lectures are on YouTube and I sometimes see people kind of taking photos, which is fine. Like I said, if people want to take photos of their, lectures or dinners or whatever, that is fine. But if you have a screen, so the easiest thing to do if you want to get the code into Paizo, it's to just do a screenshot. Thank you. Thank you. Is to do a screenshot and then just paste it into whatever ChatGPT or Claude or like your favorite LLM. So that's going to be different to different systems, but I think everyone knows how to do screenshots. I know because people send me screenshots of their code all the time, which, by the way, I mean, now it's fine because I can plug them into an LLM, but if you send me code, please like a file. So yeah, so if you do a screenshot and you just say, transcribe, it will transcribe pretty well, and then you can copy and paste. So any code so with a cell phone photo, I don't know, but any code that you just like actually get from a screen, that works 100% of the time, pretty much. So that is what I suggest people do. So the other administrative thing, I will have, so I don't want to like sit alone in my office, but if you want to talk today after lecture, you can just come here, you can just go outside and I'll kind of stay until everyone's gone. If you want to talk at 5 or 6, please email me. So if you don't email me, I will not necessarily be in the office. But if you email me, I'll stay and wait for you. So yeah, so that's today. I will try to have something over the weekend because the deadline is coming up. I will announce something on Piazza on Saturday when I know my schedule, and that will be Like I think probably mostly on Zoom. Maybe I'll come down to the office for a bit as well. Okay. So what we're doing today, so we are solving the trailing zeros problem. The n factorial trailing zeros problem. We are finishing so building the password system from the other day. And if there's time left, I will give you some hints for project one. So, okay. Guys, yeah, so that's like a problem is like in the first few weeks, nobody's friends with anyone and there's no talking. I feel like you've now made friends, which is good, but you should text. So, okay. I said text. All right. So, okay. So we are doing the trailing zeros problem. So I want to do two versions, not because it's like an especially important problem, just because it's kind of fun and it demonstrates, I think, good coding practice. So might as well. So to remind people, so again, n factorial is 1 times 2 and so on times n. And we want the number of trailing zeros. So basically, we want to factorize n factorial into 10 to the power of k times some kind of constant and find k. Does that make sense? Is that good? All right. So I think with someone in one of the front rows in MC, we had the idea of basically saying, okay, so we'll go through all the factors. We'll go through 1 and 2 and 3 and so on. And for each of the factors, we'll find how many factors of 5 there are. Okay, so that's in a way kind of easier than what you've done in the lab. So I'll do it pretty fast. So I'll do just like a num factors function. So that would be nk, and I want to return the number of times that, so the of times that n has a factor of k. And the way we do it is we just keep dividing n by k until we can't do it anymore. And that's our number of factors. So we'll do count is equal to 0. And we'll say while n is still divisible by k, do it like that, right? So that means, so stop me if that's too fast, but we had done this a couple of times before. So, which is fine, like stop me if it doesn't make sense. So we're saying if n is divisible by k, we'll divide n by k, and we'll increment count. And then at the end, we are returning count. So at this point, and this is something that you should keep in mind when doing project one, I don't want to write more code. I want to actually test the function. So the process here is I'm saying, okay, like I definitely need this. I want to make sure that it works before I proceed further. So one thing that you often see in the lab is people kind of dump their entire concept on the screen and then it doesn't work, and then they have no idea what's broken. And like, of course, because like you make typos all the time, there's like, I mean, I make typos as well, maybe kind of not as frequently as some people, but like, of course, like you write the function, you test it, and then you know that it works, and then you can proceed kind of using the function. The other thing that you'll note is that I made it more general than I strictly speaking needed, right? So I said, I need to know how many times 5 goes into n, not strictly speaking k, but like, why not? Might as well write something that would be reusable for other things as well. Though that's debatable, so let's test it. So I'll say, okay, so like number of factors in 4 is supposed to be 0, right? Because there's no factor of 5 and 4, so that is supposed to be 1. So here, let's do like 5 to the power of 3 to the power of 100 times so some prime number. What's a good prime number? 17 is a good prime number, yeah. Yeah, let's multiply it by another prime number. Just so all right. So the answer here is supposed to be 100. And I set it up so that I know that the answer is 100, even though this is a huge number. Right? But I set it up so that I know that, 3 doesn't have a factor of 5, 17 doesn't have a factor of 5. So the answer has got to be 100. So I'll print it. I did make a typo because I didn't say 5 here. And here it is. Make sense? So, okay. So what do we need? So what do we need now? Now we basically need to go through every factor in n factorial and count up the number of factors of 5. So I'll call it trailing zeros. I don't actually know if it's supposed to be zeros with an E or not. I should find out. Okay. Okay, it's thinking. Oh, okay. It's both are okay. So okay, all right. Sometimes LLMs are wrong, but I think for this it's probably correct. So okay. So what do we need to do? So we say for I in range. So we go up to n including n because n factorial has a factor of n. And we count up the number of factors of 5. So we should start with 1, by the way, because if we don't start with 1, that's not going to be great. Because here, like 0 is going to be divisible by 0, and that's going to be an infinite loop. Does that make sense to everyone? Sorry, that should not make sense. So stop talking and think. So who sees that if I started range with 0, it would be an infinite loop? Not many people. So okay, so let's focus maybe. Guys, I'm gonna wait. Back row. Back row. Hello. Thank you. Yes.
Is that supposed to say number of factors instead of function?
No, like I didn't finish writing it. So so I just stopped to see that if we compute. So if we compute the number of factors using so if we do for I in range and then we say whatever 100 and we say count factors I 5, let's say, like this. So count num factors, sorry. So what we get is an infinite loop. Why? Anyone? Yeah.
Because like if you set the function, it's just trying out how many times you can do factor k. So since 0 will never end up like getting small enough, it'll always like be equal to 0.
Exactly. So another way of saying it is how many factors of 5 are there in 0? Well, if you multiply 5 to the 100 by 0, that's still 0. So in a way, infinite. So let's debug it. So I'm pressing Control I. And I'm going here. So that is shell postmortem. We are over here. So I'll check, okay, what is 0? That is 0. What is k? K is 5. So we're saying while 0 mod 5 is equal to 0, 0 mod 5 is always going to be equal to 0. And then we say 0 is equal to 0 divided by 5. That's still 0. And we go around and around. Does that make sense? Questions? Okay. So I'll stop debugging, press this. So now what I'll do is so I already fixed it here. So if we start with 1, we don't have this problem. And here we'll say count factors is count factors 5 plus number of factors n, I5. So now that's kind of a complete solution. So if I do, whatever, so that's 1, so that's 120, if you remember. This is 720, so that's still 1. Times 7, of course, is not going to make a difference, but if you do this, then you have whatever. All right. Does that make sense? Questions? Yeah.
I was wondering, like, I feel like there's a more efficient way than
Yes.
which is to just like start with like 5.
Yeah.
And then see if n itself is like 5. How many times?
Yeah.
25.
Yeah. Yeah, I was going to ask you, but thank you. So yes, exactly. So let's do this plan. So I think like there's like multiple ways of expressing this idea, but here's the basic outline. I think that's kind of what you're saying. So we have this product. So like 1 times 2 times 3 times 4 times 5 times 10, 15, 625 at some point, and so on, right? So here is one way to think about it. We'll say, okay, like this one contributes 1 factor of 5. This one contributes another 1. So this is 5 to the power of 4, for example. So that contributes 4, right? So, okay, so far that's exactly what we've written before. But here's one way to think about it. We'll say for every time that we have a 5, so we skip over 5, I'll do a 10 here as well. So every time that we get the factor of 5, this is 1. So every time we have a factor of 5, we'll add 1. So we'll add 1 here and here and here. And then every time that we get a factor of 25, we'll add another 1. So 625, if you skip by 25, you'll eventually get to 625. And then every time we had a factor of 125, we'll add another 1. So here 125 is not visible, but 625 has a factor of 125. So if you skip by 125 5 times, you'll get to 625. And then every time that you have a factor of 625, you'll add another 1. So you skip by 625, another 625, another 625. And every time you add 1. So if you add up all of those guys, what you'll get is the number of factors of 5. Is that making sense? So like if you add up all of those 1s, so the algorithm is you are skipping by 5, and every time you skip by 5, you add a 1. And then you're skipping by 25, and every time you skip by 25, you add another 1. And every time you skip by 1 to 5, you add another 1. And if you add up all of the ones, you'll get the sum on line 26. Yeah, questions? Let's do it. So that like it's super easy if you think about it. Oh, well, like once you have the idea, all you need to do is to just like skip by 5, skip by 125, skip by 625, and you're done. So okay. So we're doing again count factors 5. So now what we got to do is we got to keep skipping by 5, and then by 5 to the 2, and then by 5 to the 3, and then by 5 to the 4, and so on. Right? So I'll name this skip by. And initially skip by is going to be 5. And then I want to make it 25, and then 125, 625, and so on. Right? So when do I want to stop? I want to stop when skip by skips over n. So I'll say while skip by, I'll come back to this condition. So I'll say while skip by is smaller or equal than n, I'll still do it. And now I'll say, okay, so start with 5. So start with skip by and keep adding 1 until you skip over n. So I'll say current is equal to skip by. And here, so this is like a little so this is like the first time that we have a while loop inside a while loop. We'll introduce, so this is like an advanced kind of thing, so we'll come back to it. Yeah.
5, 5, 5, the 4 divided by 5, and then I will just give you the count.
Yeah, you could. In fact, okay, I wanted to do this, but I think I like your idea better. So let's do that. So we'll say, okay, so we have skip by. I wanted to do like the loop, but I think you're right. This was overly complicated. So let's just say, okay, like how many times does skip by fit into n? And the answer is n divided by skip by. So we want to make sure that we are not off by 1 or something. So just to make sure, so if you have 25 and the skip by is 5, then we want to fit 5 times. That is what it is. So that's good. And now we'll multiply skip by 5. We'll return count factor 5. Okay. So the idea here is like this. So we want to know how many ones there are going to be inside of n if we skip by 5. And the answer is n divided by 5. And then we want to know how many times 25 is going to fit if we skip by 25 every time. And the answer is n divided by 25. And then we want to know how many times 125, skipping by 125 fits. And the answer is n divided by 125. So that's it. So that's kind of a bit of an advanced thing. So if you enjoyed that, then great. Otherwise, we're moving on unless there's questions. Okay, other questions? Okay. All right, let's do the passwords. So to remind you, What we want is a login kind of thing. So that is from last time. So I'll do it quickly. So assuming that this is correct, we want this to be true. And then if we log in incorrectly 3 times, okay, so that would be true. So that is false, right? So that is false because that's too high. And that could be true, but that's false. And then if the correct answer is U of t is number 5, that would still be false because if you try to log in 3 times in a row and you get and you don't succeed, that would still be false. So that's like even if U of t number 1 is the correct password. Okay, so that's the mechanism that we want. Does the setting make sense? Okay. So, all right. So let's first of all set up the data and do the thing without the lockout. So the way that we can do the data currently is the same way that we did the earnings for the majors. We can have 2 lists. One of those will be usernames and the other will be passwords. So for example, it's going to be like usernames. Okay. And then this is going to be my password. What's a good password for Roger? I don't know. I'm blanking here. Okay, so I say again. Oh yeah. Sure. Okay, that's good. All right. And then Chris Gibbs is U of T number 1. Yeah, thank you for the suggestion. Pass it on to Roger as well. Or just try to log in to U of T. It might work. Okay. So the setting here is the password for usernames at I is passwords at I. Right? Does that make sense? So let's just do a simple function that checks if the password is correct. So here, usernames and passwords, I define them as global variables. It kind of makes sense they should be because lots of functions will have access to them. So what do I need to do? So I need to find whether the username is valid at all. If it is valid, then I want to see whether it matches the password. So if you remember, the way to look up the location of an element in the list is index. So for example, if you say this.index10, that is going to give you the location of the 10. So this list at location 1 is going to be 10. You can only use it if 10 actually is in the list, which is fine for us because if the username doesn't exist, then the answer is that it's definitely not a valid login, right? So we'll just say, okay, so if username is not in usernames, so that's definitely returned false because the username doesn't exist. And the mechanism usually is that the output should be the same whether the username exists or whether the username does exist and the password is wrong, or whether the username doesn't exist, and that's so that people don't try to find out the usernames by trying to log in. So you don't want to tell people that the username doesn't actually exist, because that's like giving information to people who shouldn't have it. So, okay. So now that we have this, what do we do? So if I say usernames, index username, that is the location of the username in usernames. And now I can just use this in order to access the correct password, right? So I'll just take this. And if I do passwords at username.index username, that's the corresponding password. Does that make sense? Questions? So again, that's the location of the username. So if it's Gerjoy, it's going to be 0. If it's Carrick, it's going to be 1. If it's Yip, it's going to be 2. And then I'm saying passwords at 0 or at 1 or at 2. So it's kind of like looks like a big formula, but if you do it like step by step, so this is the location of the username, and then this is the place in passwords where the corresponding password is. So now I just want to compare it to password. And then if they're equal, that means that the login is correct. If they're not equal, that means that the passwords don't match. So that's incorrect. So that means that that is the value that they need to return. And that's it. Is that making sense? Is it too fast? I don't know. Does it not make sense? Anyway? No? Okay. So again, so this is the location of the username inside usernames. So if it's Yip, for example, it's going to be 2. Right? So then we're saying, okay, so what's the password that corresponds to element number 2? Well, it's this one. So this is passwords at 2. So this is 2. And then passwords is 2 would be the corresponding password. So this is the password. The correct password for username is this. And then we're saying, if the correct password is the same as the password that we passed, then we return true. If not, then false. So we return whether kind of the answer to the question of whether the correct password corresponds to the password that we passed to the function. Okay. So that's check password. So what we need to do now is to implement the mechanism for locking people out with 3 consecutive failed attempts, right? So, okay. So that would be like this. So now what we got to do is we got to say, okay, so this is kind of like check password, except you need to check whether you logged in and logged out, sorry, and you need to log the person out if there is 3 consecutive failed attempts. So how can we do it? Well, we got to keep track of how many failed attempts there are. So initially, the number of failed attempts is going to be 0. And then here, now that I've set up failed attempts, I'm going to ask, okay, like, is failed attempts greater or equal than 3? Then you're definitely logged out. So right away, I say if failed attempts greater or equal than 3. In fact, you could do equal to 3, doesn't matter. We return false. You are locked out permanently. So if we're on line 18, that means that we weren't locked out yet. So now we just say, okay, so if check password, username, password, then that's not a failed attempt. And that means that the number of failed attempts now is going to be 0 because you just succeeded. So we reset failed attempts to 0. and we return true. If the attempt failed, then we need to increment failed attempts and return false. All right. Does anyone see a bug in the function check password? Yeah. Yeah, exactly. So failed attempts was not declared as global, which means that this will just, which means that while this will not produce an error because it's defined elsewhere, this can produce an error because here I'm updating failed attempts and pretending that it's global while it's not declared that it's global. So I'll make it global. Make sense? So let's trace it. So I'm making it like this. So failed attempts initially is 0. Failed attempts is a global variable. So this is supposed to be true. So by the way, a trick to check whether this is actually my password is if you double click. Did not actually work, doesn't matter. Okay, so we'll step in. So is failed attempts greater or equal than 3? No. So check password is supposed to be true. Failed attempts was already 0. We return true. So now we are going to try. I'm not actually printing, so I'll print this one. And we'll see that this is false. So I'll now trace it. So at this point, failed attempts is supposed to be 3. So if I step in, what I get is failed attempts is greater or equal than 3. So I return false. If I'm somewhere over here, so at this point, failed attempts would be 1. So let's see how it becomes 2. So run it again. I step in. So failed attempts is not yet greater or equal than 3. So failed attempts, I can look it up, is 1. So now we check the password. Check password is supposed to return false. So failed attempts becomes 2, and we return false. The next time we try it, failed attempts will become 3, so that the next time you call the function, failed attempts would be greater or equal than 3, so you return false right away, and you're never able to reset. Does that make sense? Okay, so for your screenshotting pleasure, this is the full screen. So now I want to change it just a little bit. So I was developing it kind of like a little bit rough and dirty. I want to make it similar to project 1, where what we do is we initialize the global variables in the function initialized rather than in the main block so that you can call initialize multiple times. So I'll just do the function initialize. And I'll just move this over here. So in the main block, I did not have to say global. In fact, shouldn't have said global because anything that's outside the function is already global. On the other hand, inside the function initialize, if I don't say global, then those will be local variables that are not usable elsewhere. So I need to say global usernames and passwords and failed attempts. And then here I'll call initialize. Does that make sense? Question? Okay, so let's just run it again to make sure that still works. So copy that. So that's supposed to be false. And then I'll just print this. This is supposed to be true. This is true. All right. Question so far? All right. So let's make this interactive a little bit. So far, so this is kind of as far as you need to go in project one. Some people sometimes in project one are like, am I supposed to get input from the keyboard or anything? Well, no, it's just a simulation in the same way that here I'm like typing in usernames and passwords and not really doing not really doing any real interaction. You can, however, do an interaction as well. So I think we did it very briefly in response to a question, but the way you can get input in Python is say input, and then you give a prompt. So for example, username. And then what happens is this function takes an input from the user and then puts the input as a string inside from user. So I can say, for example, print you entered, and that would be from user. So if I run this, it's gonna wait for me to type this in and press enter. So, or what's a good username? That's more like a password, but whatever. So here, what's happening is I entered the password and then I printed it back. Sorry, the username. All right. So this is just like the ones. So if I want to repeatedly get input from the user, which is like what happens on the computer, right? It's like what my computer is doing right now. It's waiting for me to type something in a way. So there is always a loop that's waiting for kind of multiple inputs in a way, in an abstract kind of way. So let's do a loop. So I can, for example, ask for some kind of answer from the user. So I can say, I keep like asking so I'm saying, okay, so like while answer is not equal to yes, sorry, input, of course. I'm going to ask like, did you start project one? And I'm going to put the answer in here. If the answer is not yes, then ask again. I didn't do a space. Okay. Okay. And then once the input is equal yes, the loop stops. Does that make sense? So I put a new value or an old value in answer every time. Then I check is answer is yeah, is answer yes. If yes, that's done. If something else, then I get the input again. I had to say answer equals to something initially. So I just put an empty string in there. If I didn't have that, that wouldn't work because when I go to line 5, I say is answer equal to yes? And here it would be, well, answer is not defined. So that's bad. Make sense? So, okay. So here, what they'll do is basically a loop that keeps going on forever because, users can keep trying to log in. So if you remember, we started infinite loops with saying, well, you could say, well, true, but why would you? Well, here's why. If you continuously want to get input from the user, it's continuous. You always keep trying. So, okay. So we'll say, okay, so we'll get the username. And we'll get the password. And we'll do login. So if the login is successful, then we'll print success. Else we'll print denied or something. And we just keep going. Does this code make sense? So it's an infinite loop because we're just simulating like getting input from getting like logins. We're not doing anything about the logins other than saying like whether the login was successful or denied. And then we'll just ask the next time. So now we can do like a continuous thing. So I'll just copy and paste my password so that they can simulate it. And I'll call login loop like this. So now I can try to log in as myself. Success. Denied. And now, even if I log in with my correct password, that's supposed to be still denied. And indeed, it is. All right. Okay. So like I said, so I'm going to go outside to take questions. If someone wants to talk to me now, if you want to talk at 5 or at 6, please send me email with the time. See ya. Bye. Have a good weekend.